Okay, when price changes, quantity demanded changes. When price goes up, quantity demanded goes down, and vice versa. But how much does it change? Quantity demanded doesn't change based on a change in price, the same for every product in every situation. And so economists look at elasticity of demand, how much it changes. How responsive is the change in quantity demanded to the change in price? Is it super responsive, super stretchy? How elastic is it? And economists measure this with something called price elasticity of demand, PED. It's a measure of how much quantity demanded changes for a given change in price. Now we know there are about 5 rules that determine how elastic demand can be. The first is availability of close substitutes. If you have close substitutes, close subs, then the response tends to be elastic. I'll abbreviate with EL. Why? Well, think about it. Let's think about Coke, Coca-Cola, okay? Let's say Coke doubles in price. You're going to buy less Coke, true. But how much less? Well, probably a lot less, because you can drink Pepsi, Diet Coke, Coke Zero. You have a lot of close substitutes. So since you can turn to those, you're going to buy a lot less Coke because of that price change. So in other words, your response is going to be very big. It's going to be very elastic. However, let's say the price of eggs doubles. Eggs are kind of unique. There's no really good substitute for eggs. There's powdered eggs and liquid eggs, but those are made from eggs. So you may buy less, but not that much less, because there are no close substitutes. The second rule is the share of budget spent on the good. And a big share of the budget, big, equals elastic. Think about something small, gum. Let's say gum costs 50 cents and it increases 50% price increase. It's a huge increase to 75 cents. But you don't really care. You still buy about as much gum because it's such a tiny proportion of your budget. However, if a car you're contemplating buying increases by 50%, the price increases, you're going to be much less likely to buy it because that's a huge proportion of your budget. Big proportion of your budget equals elastic. All right, rule 3, necessities versus luxuries. Luxuries equals elastic, and you can kind of figure this out pretty easily. Let's say you're diabetic and the price of your insulin goes way up. Well, you may try and live with a little less, but you're going to buy about the same amount because that is a necessity. It's going to be an inelastic response. But if the price of European vacations skyrockets, you're going to be much less likely to go ahead and buy one because it's a luxury. You don't have to buy one. Luxuries equals more elastic response. Rule number 4 is definition of the market. If we define something very narrow, then it's going to be elastic. For example, Ben & Jerry's Cherry Garcia ice cream. That's a very, very narrowly, the market for that is a very narrowly defined market. It's a very specific market. And if the price of that particular product doubles, I'm much less likely to buy it because of relating back to rule number 1. I have lots and lots of substitutes. I can get a different flavor of Ben & Jerry's. I can get a different brand. I can get chocolate ice cream. I can get frozen yogurt. I have a huge number of options. But if I define this market as broadly as possible, food, well, my demand for food is inelastic. The price of food in general goes way up. I've still got to buy food. So narrow equals elastic, broad equals inelastic. Rule number 5, and finally, is the time horizon. And in this case, a long time horizon yields the elastic response. Let's say the price of gas goes to $10 a gallon right now. In the short run, you're going to buy less gas, but not a dramatic amount less because you don't have time to adapt. But in the long run, if the gas stays that expensive, you may buy a more fuel-efficient car, you may ride a bike more, you may carpool, you may make arrangements. So over the long term, you will have a fairly inelastic response, but fairly elastic response. But in the short term, your response is going to be rather inelastic. Now, it's very easy to compute the PED. It's the percentage change in quantity demanded over the percentage change in price. Let's say, for example, that something goes up 10%, and the quantity demanded, therefore, falls by 20%. That yields a PED of 2. What does that mean? We'll learn more about that later. But you could either divide 20 by 10 or 0.2 by 0.1 as long as you use the same format in both the numerator and the denominator. Super easy formula. Now, there are 5 categories, different varieties of demand, and they correspond to that number, that PED number. First is perfectly inelastic demand. Now, that would be a demand curve that would be straight up and down. And the elasticity is 0. Any given change in price yields 0 change in quantity demanded. 0 over anything is going to be 0. What might this be? I don't know. Insulin, perhaps, for that diabetic. Heroin, perhaps, to an addict. He didn't care what the price is. That's perfectly inelastic. A PED of 0. Now, inelastic is a PED of less than 1. And that's a fairly steep demand curve. What that means is, for a given change in price, the change in quantity demanded will be somewhat less than the percentage change in price. Therefore, the response is relatively inelastic. Category number 3 is unit elastic. It's an elasticity of exactly 1. You divide the percentage change in quantity demanded over the percentage change in price, and you get a 1 because they were the same. Price goes up 10%, quantity demanded falls by 10%. That's considered unit elastic. PED equals 1 exactly. Category 4 is elastic, an elasticity of greater than 1. A given change in price yields a greater percentage change in the quantity demanded. That's a fairly shallow demand curve, and it means that the response is significant. So anything over 1 is considered elastic. The final category is, frankly, kind of academic. Even I struggle to understand it. It's perfectly elastic demand. And the demand curve would look like this. For example, in this graph here, at $4, consumers will buy any quantity. And at anything over $4, they won't buy any. I don't really know what an example of that would be, except perhaps $4 bills. But theoretically, an elasticity of infinity would be perfectly elastic demand. Maybe some of you physics geniuses can explain it to me.